Greetings and welcome, friends. Mr. Waddy here. Today we are going to learn what I would feel is the most powerful form of a quadratic equation, at least when it comes to its usefulness for graphing. We're talking about a vertex form of a parabola, where we're going to be able to think about it in terms of vertical and horizontal shifts or transformations, or more specifically, translations is when you shift a graph. And then the A is going to be our stretch vertically or smoosh, respectively. The A, when it's negative, you guys know that it flips the graph upside down. So it says when h is greater than 0, all right, the number inside the parentheses. So notice this time we've got x minus h inside the parentheses all squared. That it's going to shift the graph to the right, like so. And when h is negative, it's going to shift the graph to the left. All right, h units, right? So that's all it's going to do. It's going to change the location of our vertex. Notice it conveniently uses the letter h, which will correspond to the x-coordinate of our vertex, oddly enough. Here they've given us a somewhat simplified version of our graph, where it will always happen to have a vertex on the x-axis. But later on, we'll move on to the idea with when there's a plus k. And tell you what, I just added that right there. Let me show you this little graph that I made, not unlike the one that we just had. And notice, it shifts it. Now, the other benefit of this form is that the shape of the graph allows us to continue to use our quote-unquote slopes technique, whereas last section we were not able to when it wasn't in this form. So the A will actually affect the slope. So right now, since A is equal to 1, this is literally going up 1 over 1, up 3 over 1, up 5 over 1. Let me actually zoom in just a tad for us until I get, there we go. Now you can see that it's actually going the up 1 over 1, up 3 over 1, up 5 over 1, etc., right? And so it is moving by my slopes. So all I have to do is think about where is my vertex and move by my slopes. Watch me move by my slopes, right? And so that's perfectly good. The other thing I want to point out with h, just like when we were shifting absolute value graphs, is that it's minus h. So it's going to be kind of like the opposite of the number that you see as far as what h value you pick. And since we're here, I'll show you how k works as well, and it behaves exactly as it used to with absolute value graphs, right? It shifts it up k units or down k units, right? So lovely, very intuitive approach. It behaves exactly the same way it did with our other graphs. And then, like I said, these slopes behave the same as they did back before we had the b term show up. And instead of, even if it's not up 1, 3, 5, 7, etc., you can also stretch these, right, by whatever your a value is. I can also turn it upside down like so. So you guys have the hyperlink to this graph in your notes, if it helps, if it's something that you want to play with. Also notice I can do the up 2 over 1, up 6 over 1, up 10 over 1 graph when I double my consecutive odd number slopes, right? Quote-unquote slopes. I realize I'm going to get some emails and comments from mathematicians. They're like, those are not slopes of parabolas. And that's why when I say slopes, I'm putting it in quotes. 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 Slopes. Slopes. Quotes. There. All right. So let's take a look at this, shall we? It says, yeah, you can shift it around, basically. All right. So it says, let's graph this, and when we graph it, it says then compare it to the parent function, right? Because these are all just transformations of a parent function. Okay. All right. So let's label some of what we know. So I know that a is equal to a half. All right, the number in front, right. And I know that h is equal to positive 4. So it's the opposite right? It's the opposite of the number in there with the x. And actually, I could even go as far as saying that k equals 0. So my vertex, when I combine that information, is going to be 4, 0. All right, so actually, let's just plot that point right there. Oh, lovely. Lovely little vertex. Yeah, I'm going to insert a cough drop here. Slopes. Quopes. Whips. So, now in terms of our slopes, this one's a tricky one. Normally I go up 1, over 1, up 3, over 1, up 5, over 1, etc. But I'm going to have to multiply these numerators by my a value. So a half times 1, and a half times 3, and a half times 5. So these semi-simplify. I'm just going to simplify the numerators. It's going to be going up a half over 1, up 3 halves over 1, and up 5 halves over 1 when I just multiply the numerator by the 5, the 3, and the 1. And so for my y-axis, I'm actually going to count in halves. All right, so instead of going having the tick mark where it currently is at 1, I think you guys can see that. I'm going to add some extra tick marks here. Ready? Let's tick it to ride. All right, so there's a half. Actually, I'll just mark the half ones. There's a half. 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 And I tried to pre-build my graph so I had the spacing for it. And so, yeah, I'll show you how it works. So starting from the vertex, I'm going to move up a half and over 1. So I'm going to go up a half unit and over 1. And I can also go up a half and backwards 1 if you want to mirror that at the same time over our axis of symmetry, right? And then from there, I'm going to go up 3 half units. Right, so here's 1 half unit, there's 2 half units, there's 3 half units, and over 1. And then from here, I also could go up 3 half units and over 1. And then up 5 half units, so 1 half unit, right, I'm counting by these half marks, which makes it easy. 1, 2, 3, 4, 5 half units and over 1. And then I'll do the same thing over here, up 5 half units and over 1. Okay? And the axis of symmetry, right, I didn't draw yet, but is like so. And that's how I could have mirrored those other points quite quickly. Right? So using my slopes is just such a great way to be able to represent this. Ready? Whoa! Oh, the world is upside down. It's all over. Oh, the humanity. Oh dear, I just zoomed a little bit. Oh dear. Oh dear. I forget which way to do it. Snap. There we go. All right. Almost did a good parabola there. Yep. Yeah, I swapped the gravity on this level. So let's see, and I'll flip it back. Oh dear. And let me fix my zoom. Go back to zoom standard. And that's on the wrong spot. There we go. So I've got my parabola. I was able to graph it. Now, in terms of answering their question, they wanted to compare it to the parent function. This was a horizontal shift. Right, how many units? How many units right was it shifted from the parent function? How many units was that? Yeah, so it's shifted based on the h value, so 4 units. And then it was a vertical, what I call a smoosh. And I'm just going to use that word. By a half. Right? So in terms of transformations, that's what occurred to my graph. Now, my grid, because I stretched the y-axis funny, it doesn't look as smooshed as it actually is. So just be aware of that. Be careful. Be careful. Let's see. Let's I might have missed something here. That's fine. Let's do example 3 here with the pre-built grid. Were you guys able to write this down yet? Were you caught up? You need me to up? I take that as a yes. Okay. Whoa. All right. So this one's got the plus k in it. All right. This one, they added that. That's just going to result in a vertical shift, right? The k value, all that does is vertically changes the location. It does not affect the shape of the parabola, notice. Right. And this is just the horizontal shift. The only thing that affects the shape of the parabola is the a. Okay? Question? Let's see. Let me take a look at mine. Flip a few pages. I did skip some of the monitoring progress questions. Yeah, you just gotta, yeah. So there's example 2, then there's monitoring progress 4 and 5, and on the next page says example 3, and it'll match this. Yep, I skipped around. You're right. I did that on purpose, though. Yep. Edited for content. Yeah. So, let's figure out, let's see. Someone help me out here. Micaiah, could you tell me what do you think A is for our equation up here? Yeah, so A is the -2. Right? And let's see. Brandon, welcome back. What do you think H might be? H can be the tricky one. And it's going to be the opposite of that. So H is the tricky one. And Brandon, just to give you the redemption, what do you think the K is going to be? That one keeps the sign, right? That one's a match. So that's a +3. So my vertex, if I combine that information, is going to be at -2, 3. So let's see, for my graph, make sure you check your axes, make sure it's counting by ones. So -2 and 3 is where my vertex is. And I guess I can draw the axis of symmetry here. Let's see. No, the 5s are all that was labeled, but I don't know if you can see, I do have tick mark, the grid that's barely visible. Those are counting by ones. Let's see, the axis of symmetry. Austin, do you think you could, you know what the equation of the axis of symmetry is? X equals what? All right, it's always x equals, and it will be the x coordinate of the vertex. No, let me see. For the vertex, all right, vertex. I went left 2 and up 3 to plot that point. So -2, right? Because this is x, then y. So no, I got it. I did have to double check myself though, because yeah, I'm known to make mistakes. Okay, so Kayla, what are the normal slopes? Ignoring what our a value is here, what are the normal slopes of a parabola? Do you remember? The what over 1, the what? Yeah, 1, 3, and 5. Thank you. So up 1 over 1, up 3 over 1, up 5 over 1, etc. And in this case, I'm going to take the ups, the rises, and multiply by -2. And I'm going to make sure this looks like a multiplication and not a decimal. So -2 times that, and -2 times that. So, Tyler, what do you think these are going to simplify? -2 times 1 is going to be a new slope of what? -2 times 1? Yeah, so down 2 over 1, and then what? Yeah, we're multiplying. And then negative 2, 5, be down times what? Negative 10 over 1. Okay, so these are going to be our actual slopes. And our tick marks were all good. So let's see, from the vertex, let's go down 2 and over 1 and plot a point. And you can pre-mirror that point. You can save your mirror for the end, or if you want to mirror all along, doesn't matter to me. So down 2 over 1. From there, I'm going to go down 6 over 1. And let's mirror that. Mirror, mirror. Mirror. And down 10, I can't even fit, but that's fine. I've got 5 points on the screen in the window. So I'm happy with that. How would I have known it opens down before I even... Right, I determined that based off of the A value. Right, obviously it's pretty clear now, but yeah, it opens down anytime A is negative, right? And so, Micaiah, since it opens down, does this have a minimum or a maximum? A maximum. And, Kayla, what do you think the maximum value is? What's the highest it gets? No? The highest it gets is going to be at the 3. All right, so the axis of symmetry is related to the x-coordinate of the vertex, and then the max or min will always be the y-coordinate of the vertex. They didn't even ask us for all that information. I just figured, you know, let's start trying to pull all of our stuff together because there's so many things about parabolas that we've learned. So in terms of transformations, right, if I want to think about it in terms of transformations, this was a horizontal shift. Right 2 units. Nope. Left 2 units. Right, and that's determined from the H. I moved left 2, and then I did a vertical shift up 3, and then it was a vertical stretch. By 2, so it was doubled, right? Everything was doubled. That's what we saw here. And the minus sign was a vertical reflection. I could call that. I could also say it was a reflection over the x-axis. Nope. No, actually, the reflection, I just realized, would have to take place before I did my vertical shift, which even in terms of PEMDAS makes sense because multiplication takes place before addition. Aha. So I'm actually going to draw an arrow here. The reflection had to occur before the vertical shift, because if I reflected this, it actually would have been like that. So yeah, that's a little weird, but no worries. We fixed it well enough. So there's example 3. So these problems I don't think are that crazy. Let's do one more like this. Do you guys want me to do 6 or 7 on that page that you see? Yeah, 7's got the fraction there. So yeah, we'll do 7. And then if you guys ever want to practice or when you're studying for a test or final, you could go back and do 6. Wanted. All right, and now I've been pre-making our grids for us, but I just want to point out, I can analyze this, right? I'm thinking that this is going to be a vertex that was down 2, and then it's still opening up. So when I imagine the window in my head, I've got to make sure that I can go down 2 units and that there's space for it to open up. Is what I kind of do. And then also in terms of the horizontal shift. So as I'm picking my window, that's why I did it where I did. Kayla, question? Yeah. All right, let's see. Austin, what is the A value for this graph? A half? And based on that A value, do you think it opens up or down? Opens up. And is this a vertical stretch or smoosh? Smoosh, right? Because it's a number that's between 0 and 1. Aha, there you go. All right, let's see, Micaiah, what's the value of h? This is the tricky one. -4. And let's see, Tyler, what is the value of k? A, H, K. -2, and it keeps the sign right there. So my vertex, Brandon, is going to be what value? Wait. -4, -2. So let's plot that point. But notice my scale is all wonky. All right, so here's 5. Okay, no, I'm counting by whole units here. Okay. So -4 is over here, and then down 2 is right there. So there's my vertex. Let's see. Tyler, what do you think? They didn't ask for this, but what is the axis of symmetry? What's the equation of that? Yeah, it's always x equals a number. Yeah, what number would that be that would describe this axis of symmetry? -4. Yeah, right? It's always just going to be the x-coordinate of the vertex. The equation of a vertical line is just x equals a number, and that number is either where it crosses on the x-axis, but for us, we care about this vertex more, and they're both the same thing. So let's see, for my slopes. Normally it's up 1 over 1, up 3 over 1, up 5 over 1. But I've got to multiply all the numerators by a half. And we did that on I think we did that in this video already. So up a half over 1, up 3 halves over 1, and up 5 halves over 1. And that means I'm going to want to count by half units, right? So I'm going to add some tick marks here halfway. Now, if these were thirds, I would have added tick marks at the third spot. So I would divide each full space into 3, which means I would have needed 2 tick marks. Or if these were 4s in these denominators, then I would add tick marks that would divide a full unit into 4, meaning I would have needed 3 tick marks. All right, so you're going to want to change your scale, and it'll make things so much easier when we move by our slopes. All right, so I'm going to move up a half and over 1. And then up 3 halves and over 1. Then up 5 halves. Let's see, 1, 2, 3, 4, 5. There we go. And over 1. And then I can just mirror those values, right? So let's see if I can draw right side up parabola any better these days. Ah, terrible. Let's see, maybe if I come down from this side. Yeah. There we go. Golden arches there. Hey, Ronald McDonald. All right. And I think we're good for today. We're gonna do some practice in class, and then I'm gonna make a part 2 of this video where we'll model some real world situations. All right. So thanks for watching, internet friends. Have a great day.